I hope everybody is back. All right, so we are now going to start with combinations with identical objects. Combinations with identical objects. Now the topic may sound to be very trivial because most of you would know that if you are trying to select, let's say I give you a question, very simple question to begin with. So let's say there are 5 pens, okay, and these all pens are identical. They are of the same brand, exactly same structure, color, everything is same. You cannot distinguish between these 5 pens. And I ask you, select one pen from this. Choose one pen from this. How many ways can you do that? Will you say 5C1? Especially those who are like still living in this NCR world. Will you say 5C1? No, the answer is only one way. Correct. Correct, Aditya. Yes, Gayatri, you will not say that. The answer will only be one way. This answer will only be one way. Because if you choose any one of these 5 pens, right, it will not be different from any other. Are you getting my point? So any pen you pick up and you show it to a person, he will say, boss, you have picked up the same thing. This is not a different combination for me altogether, right? So the number of ways to pick up one pen from 5 pen will always be only one way. No other way is there. Okay. In the same way, if I say, if I want to choose 2 pens, that will also be one way. Correct. Right? Choose any 2. Doesn't make a difference. The combination is still the same. Correct. If you want to choose 3 pens, still one way. Correct. 4 pens, still one way. Okay. 5 pens, still one way. Okay. Or if let's say if I want to add something here, 0 pens, 0 pens, that is also one way. Don't pick up anything else. Okay. This is also important to know because it is very useful for us. So what I want to say here is that, number one, if you have n identical objects, okay, then the number of ways to choose, any R objects from them is always 1. That's it. Okay. Number 2 conclusion that I would like to discuss here with you is that if you have n identical objects, okay, then the number of ways to choose at least one object is going to be n. At least one object means, let's say there are n objects, you can pick 1, that is one way, 2, that is also one way, 3, that is also one way. Like that you can go till n, that is also one way, right? So 1, 1, 1, 1, 1, n number of times, so that will be n way. And the third thing that is very important, if you have n identical objects and you want to choose none or more objects means you can choose even no object at all, then it will be just n plus 1. Okay. Now most of you, we would be thinking that, oh, this is so easy, it doesn't even require any kind of a discussion. Why is sir discussing this with us? Because it is very easy, everybody knows it. Now guys, it looks easy, but when it comes to problem solving, trust me, many people make mistakes. Okay. Let us start with a question. If you have understood this concept and it sounds very easy to you, let's do a question. Okay. The question is, let's say there is a fruit basket. Okay. This fruit basket contains 5 apples, which are all identical. Okay. 3 oranges, they are also identical. Okay. And 4 guavas. They are also identical. So all these apples, all these oranges, all these guavas are identical. Okay. My question to you is, How did you get n? See, Anurag, if you have 5 objects and I ask you to select one object, how many ways can you select it? One way. 2 objects, one way. 3 objects, one way. 4 objects, one way. 5 objects, one way. So if I say select at least one object, you will say 1 plus 1 plus 1 plus 1, 5 only. So if there are n objects, it will be n only. Correct? Anurag? Yeah. Okay. So I have a question for all of you here. So this is a fruit basket which contains 5 identical apples, 3 identical oranges, and 4 identical guavas. Okay. In how many ways can one pick? Number 1, at least one fruit of each kind. Number 2, in how many ways can you pick at least one fruit? One, I forgot to write. At least one fruit. So I've asked you 2 sub-parts in this question. The first sub-part is, in how many ways can you pick up at least one fruit of each kind? And the second part is, in how many ways can you pick up at least one fruit? I would like you to first give me the answer for the first part. So first part, please put forth your response on the chat box. Question is clear, everybody? Okay, Hariharan, very good. Okay, Anurag. Anybody else? Okay, Aditya. So 3 answers from 3 people so far. So at least one of you is wrong. There cannot be so many answers. So as I told you, people think that this concept is very easy, but when they start solving questions, a lot of mistakes come. One of you has actually made a mistake in your fundamental principle only. That means you're not sure whether you have to multiply it or add it. Okay. Okay. So let us say you go to this, let's say this is a fruit shop. Okay. Fine. And you go with 3 containers. One meant for apple. Okay. Let me make a bigger one so that we can try to accommodate a lot of numbers over here. So let's say one meant for apple, one meant for keeping oranges, and one meant for keeping guavas. Okay. So let's say you are a customer. This is a shop. Okay. And you are a customer. You went to this shop and your parent has asked you to pick at least one fruit. Okay. So you go to the shop and you see that this guy only has 5 apples, 3 oranges, and 4 guavas. And the mandate that comes from your parent who have sent you to the market is you have to pick at least one fruit of each kind, whatever you see in the shop. Okay. Now, how many ways can I pick apples? Either I can pick 1 apple, or 2, or 3, or 4, or 5, right? So there are total 5 ways to pick this up. Either you can pick 1 apple, or means plus, 2 apple, or 3, or 4, or 5. So 5 ways to pick an apple. No doubt about it. Similarly, you can pick either 1 orange, or 2 orange, or 3 orange. So 3 ways to pick orange. Either you can pick 1 guava, 2 guava, 3 guava, or 4 guava. 4 ways to pick up the guava. Okay, now what should I do with these numbers? Should I add them or should I multiply them? Now, some people have added them. Now, when you add them, it means if you just pick up an apple or one apple or two apple or three apple, your job is done. Is that the case, Vaibhav? And same goes with Aditya. Is just picking the apple doing the job that your parents have asked you to do? Your parent asked you to pick at least one fruit of each kind. You just pick up apple, let's say whether 1, 2, 3, 4 or 5. Is your job done? Is your task completed? No, then why are you adding it? Guys, we are in the second last session of competition combination. If you still don't know when to add it or when to multiply it, then you are back to square one. You are not doing your homeworks carefully. Okay, so ask yourself, if I'm adding it, my job is done individually by doing this or this or this, which is not the case. So I can't add them. So I have to multiply them because I have to fill something in these three baskets. Okay, so my answer will be 15 into 4, which is 60 ways. None of you could answer it, by the way. Okay, none of you could answer this. Okay, it looks an easy concept, but trust me, people make mistakes. So the answer to the first part is 60 ways. Now, second part. Take a clue from this, think hard, don't be in a rush, and try to answer. Second one answer, I've already got the right answer from somebody. Okay, anyways, I'll see your response. Okay, Pooja. Good, Aditya. Okay, Madhav. Okay, Anurag. Up till now, just one person has given the right answer. So you must be assuming, oh, I think it's me. Very good, Madhav. Okay, Gayatri. Okay. Very good. I'm very happy to see at least you all participating in this. The answer is actually 119. The answer is actually 119. Now, how? Let's discuss. See, again, for the second case, again, you go with these three baskets. Now, this time, it is not necessary that you have to pick up any apple. Okay. So you may end up having no apple also. That's one way. One apple, two apple, 3, 4, 5. That means total is 6. Right? Now, this is one way here where this bucket is not filled up. That means you have nothing in the apple basket. So try to understand here, when you're picking at least one fruit, you may not even pick any apple. So that one extra case will come into picture. Are you getting my point? Similarly, you may not pick up any orange or one orange or two orange or three orange. That means 4. Okay. Similarly, you can pick up no guava, 1 guava, 2 guava, 3 guava, 4 guava. That means 5. Correct. Now, since you have the mandate to either put something or nothing in these 3 boxes, that means these 3 boxes should either have something or nothing in it. That means your job is to multiply it. But the answer that you're getting from here is 120, which is not the right answer, because this also includes one cases, or you can say you can also include one such case where you have put nothing at all in these baskets. Let's say you have decided to go with no apple, you have decided to go with no orange, and you have decided to go with no guava. That is also a part of this 120. Correct? So one such case where you have put nothing at all, has to be removed because you have to pick at least one fruit. So your answer is 119 ways. Are you getting this point? Why -1 is that clear? Because there is one such case where you will put nothing at all in any box or in any of the baskets that you are carrying. That one case where you have put nothing at all has to be removed. Absolutely, Pranav. Okay, so this answer was correctly given by Pranav. I think he responded quite late, but it's fine. Madhav gave later on, and Aditya. Rest all were like messing this up. Okay. Now this concept is directly related to the concept of divisors of a number. Okay. Now let us take a concept here. How it is related to the concept of divisors. Let me ask you a simple question. How many divisors or how many positive divisors, let me ask you, how many positive divisors or positive factors, you can say, positive divisors / factors. What happened to my writing here? Yeah, / factors are therefore let's take a number. One second, I'll take a number. Yeah, let's take a number 54. Okay, how many divisors or factors are there for the number 54? Now I'm sure most of you would actually count it out. You'll say 1, correct? You'll say 2, correct? You'll say 3, correct? 6, right? 9. Okay. Anything then direct 27? Oh, 18. 18, correct? 27, correct? 54, right? So altogether you got 8 divisors or 8 positive factors for this number, correct? Now this was a small number. This was a small number and hence you could list it out on your fingertips. But what if I give you a bigger number? How would you figure out how many divisors that number has or how many positive divisors that number has? I want you to think from whatever we have done so far. I mean, after the break, so far after the break. Try to link the concept of selection from identical objects to crack this problem statement. Okay, Anurag, very good. Very good suggestion. Wow, Aditya has given a very wonderful answer. He's saying prime factorize this, which is actually 2 into 3 to the power 3. Correct? Now he's saying consider these prime numbers to be like apples and oranges. So let's say this is an apple. Very good. And this is an orange. Correct? Right? Now think as if there's one apple. There's one apple in a, you can say, fruit basket. And there are 3 oranges in a fruit basket. Can I say picking up a factor is like picking none or more fruits from this basket? Can I say that? Can I say the number of ways of making a factor is like picking up none or more fruits from this basket? Now how? I'll show you. So let's say I pick one apple. So if I pick one apple means I have picked a factor 2. So 2 is a factor. Okay. Let's say I pick one orange. Then it is like picking the number 3, which is one of the factors. Correct? Let's say I pick one apple and one orange. It's like picking 2 into 3, 6, which is another factor. Are you getting my point? So if I pick everything, that means I'm picking 54. If I pick nothing, that means I'm picking 1. If I pick 3 oranges, that means I'm picking 27. Are you trying to connect it now? So basically what I'm trying to say is that your factor picking up is like picking up none or more fruits from the basket. So if you pick up nothing at all, it will be like one Madhav. Are you getting my point? Okay. So if you have to answer this question, how many ways can you pick none or more fruit from this? Then you'll say again, same story. Take two containers, one for apple and one for orange. So either you can pick no apple or one apple. Either you can use no orange, one orange, two orange, three orange. So it is 2 into 4. Answer is 8. So that's why the total number of factors that came out was 8. Interesting, right? Okay. Now, some of you who are prepared for Olympiads and all would be aware of Euler-Tocian function. Okay, sigma and tau and all those things. So that is related to this concept, especially those who are prepared for PRMO and RMO exams. Is this fine? Okay. So let me ask you another question related to the same. So question 2 from for you is, what is the sum of the positive factors of 54? Factors of, or sum of positive divisors, factors or divisors, whatever you call it, both are same thing, of 54. Okay. Now think, don't just sit and count, add these numbers. Okay, I'm not interested in you solving the particular problem. Think as if you have to solve it for a bigger number. How will you solve it? And let's say if you have to come out with a formula, then what formalization you will do? Think in terms of that. Okay. Now let me help you with this because time is less and we have to cover a lot of things. When you pick up a factor, let's say these are the factors. One, I will write it down again. 1, 2, 3, 6, 9, 18, 27, 54. Okay, these are your factors. You see that every factor is a combination of 2 and 3. That are the prime factorization of that number. For example, this is 2 to the power 0, 3 to the power 0. That means if you don't pick any apple and you don't pick any orange, you will be left with 1. Okay. This is like you pick one apple, no orange. This is like you pick no apple, one orange. This is like you pick one apple, one orange. This is like you pick no apple, 2 oranges. This is like you pick one apple and 2 oranges. Okay. This is like you pick up no apple, 3 oranges. And this is like you pick everything. Correct? Now, when you are adding it, a bit of reverse engineering will tell you that it is actually obtained when you multiply these two guys. So when you multiply this with this, you can see that all these terms will start coming out in the multiplication, isn't it? So when you multiply these two, this term comes out, correct? When you multiply this two, this term comes out. Similarly, when you multiply these two, this term comes out, right? Are you getting my point? So all the 8 factors that you are looking at will come out from the multiplication of 2 terms from here and 4 terms from here. So altogether 2 into 4, 8 factors will come out, and those will be these factors. In other words, the sum of these factors would be nothing but 1 plus 2, which is 3, into 1 plus 3 plus 9 plus 27, which is like 3 into, I think this is going to be 30, 40. So 120 will be the sum. Are you getting my point? So from here, we'll now talk about a generic formula for this. So let us go to the next page and try to devise what is the generic way to find out the total number of factors and the sum of all the factors. By the way, before we move on, one simple terminology which I would like to introduce over here. When you say improper factors are basically the number 1 and the number itself. Okay, these are called improper factors. Okay, so if somebody says, what are the total number of proper factors of 54? You will not count 1 in 54. Okay, so your answer will be 6 in that case. So that is not a difficult thing to address. You basically see total number of factors minus 2. Okay, so why I'm telling you this upfront, because I may give you a question where they will ask you the total number of proper factors, so you should know how to deal with it. Okay, now my question here is, how do we generalize whatever we have learned so far? So if a number n is given to me, okay, which is factorizable like this: p1 to the power alpha 1, p2 to the power alpha 2, p3 to the power alpha 3, da 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 da, till pk to the power alpha k, where p1, p2, etc. are prime numbers. Okay, they are all prime numbers. For example, you wrote 54 as 2 into 3 to the power 3. So p1 is like 2, p2 is like 3, alpha 1 is like 1, alpha 2 is like 3. Okay. So let's say a number is prime factorized or written in a canonical form like this. Then the total number of divisors, positive divisors, we're not counting the negative ones, a total number of factors, whatever you want to call it. This will be, note down, alpha plus 1, alpha 2 plus 1, alpha 3 plus 1, and so on till alpha k plus 1. Okay, just recall what we did in the previous example. So we had 54, 54 was 2 to the power 1, 3 to the power 3. So the total number of factors would be 1 plus 1, which is alpha 1 plus 1, and 3 plus 1, which is alpha 2 plus 1. So it came out to be 2 into 4, which is 8. Okay, so please note this down. Now again, let me tell you, even though I'm giving you a formula, question may be tweaked and this formula may go for a toss. So don't believe in remembering formulas. That is not going to help you out. Always know where the formula comes from. That is more important. Now, sorry, not total number. What is the sum of the divisors? So for that, the formula is, now remember, what did I do in the previous example of 54? I did 2 to the power 0, 2 to the power 1. So it is like p1 to the power 0, p1 to the power 1. It will go all the way till p1 to the power alpha 1. Okay. Similarly, p2 to the power 0, p2 to the power 1, all the way it will go till p2 to the power alpha 2. Right? And same will go with pk also. Pk to the power 0, pk to the power 1, all the way till pk to the power alpha k. Now don't be scared of these expressions. These are basically geometric progressions. Okay, each one of them is a geometric series. And I'm sure you would have heard, you would have learned geometric series formula in school also. So this is p1 to the power alpha 1 plus 1 minus 1 by p1 minus 1. This term, the second one is p2 to the power alpha 2 plus 1 minus 1 by p2 minus 1. Anybody who doesn't know anything about geometric progression, I mean, completely blank, no idea about what is a geometric progression. I don't think so. All of you know a bit. Madhav, I have taught you so many times in the bridge course. You can't say that. Officially, this chapter is not done, but that doesn't mean you know nothing about it. Okay, never mind. If you can solve it by this way also, it's fine. I mean, the numbers will not be that big enough. By the way, just to give you an idea that if you have a geometric progression like this, the formula is a r to the power n minus 1 by r minus 1. So all these results that I have written is based on this formula. Okay, so please remember this. Right? As you can see, a here is 1, r is p1, and goes all the way till alpha plus 1 terms. Remember, it is alpha 1 plus 1 term. So n will become alpha 1 plus 1. So a is 1, r is p1. Okay, that's how we got this formula. Now it is understood. Roughly, you should know how these formulas work. This I didn't know. Okay. All right. Now, time for some question, guys. Time for some question, because knowing it is not enough. We will have to take up some questions. Actually, I wanted to do a lot of questions with you, but okay, let me give you a question from my side. If your n is, let's say, 38808, okay, find number one, the total number of positive divisors, okay. Number two, total proper divisors, proper, or you can say total positive proper divisors. I may not be writing the word positive always, so please be aware of it. Okay. Third, total even divisors. So how many even factors are there? Okay, positive even divisors. Total positive odd divisors. Okay. How many perfect square divisors are there? Positive perfect squares divisors are there. And finally, what is the sum of all the divisors? Sum of all divisors. So as you can see, I have framed 6 questions out of this simple concept. So total number of divisors, total number of positive divisors, total number of positive proper divisors. I think 1 and 2 are more or less same. Total number of even divisors. So how many divisors are even? Total number of odd divisors. So how many of them are odd? Total number of perfect square divisors. So how many of them are perfect squares? And finally, the sum of all divisors. Sum of all positive divisors. Positive, I have to write every time. Yeah, let's do this. First one first. And one more thing I'll add over here. 7th part. In how many ways can you write? How many ways can n be expressed as product of two of its divisors? Expressed as product of two of its positive factors. 7th part of the question. Yeah. Yes, first one. Anybody? Any braveheart? Okay, Gayatri says 10. I will not speak out what she said, else everybody will start giving the same answer. So Gayatri, very good. Anybody else? Okay, first of all, we'll prime factorize this because without that, nothing will move on. Okay, the biggest number I can think of is if you take the even ones, 11, 19. 11, 19, 19 minus 8 is 11. 19 minus 8 is 11. Yes, so it is having a factor of 11. So this will give me 3, 58. So 5, 3, 0, 28. Correct. Next 7, 5, 0, 4. Next 3, 168. Again a 3, 56. Again a 7, 8. 8 I know. 2, 2, 2. So can I say this number 38808 is prime factorizable as 2 to the power 3, 3 to the power 2, 7 to the power 2, 11 to the power 1. Okay, 2 to the power 3, 7 to the power 2, 3 to the power 2, 11 to the power 1. Is that fine? Okay. So total number of factors, we can use our formula. Thankfully, formula can work directly. So total number of positive divisors here would be 3 plus 1, 2 plus 1, 2 plus 1, 1 plus 1. That's nothing but 4 into 3 into 3 into 2. How much? 12 into 6, 72. Okay. So total number of divisors is 72. Gayatri, why did you get 2 less? Okay. Anyways, that's the answer for the second part probably. Yeah. So total number of divisors is 72. Total number of proper devices is 70 because you have to subtract the number 1 and 38808 from it. Okay. Is it fine? Oh, you gave the second answer first. Okay, fine. No worries. Let's talk about the third case. Now, how would you solve the third case? That's the question that you need to think of. How many even divisors are there for this number? How will you do that? And what is the trick for that? Very good. Very good. That's the trick, Aditya. Well done. Aditya, Pranav, you have cracked it. So in order to pick a factor which is a multiple of 2, remember you have to pick at least one fruit called 2. So again, think as if you have a basket where there are 3 fruits. Okay, so there's a fruit called 2. Okay, this is a fruit called 2, and you have 3 fruits like this. You have 2 fruits called 3. You have 2 fruits called 7, and you have 1 fruit called 11. Okay, so in order to pick up a factor which is a multiple of 2, you have to pick at least 1 2. Correct? That means this 3 plus 1 will not come, only 3 will come, because you can pick 1 2 2 2 3 2. Getting the point? While for the other fruits, you can pick either 1 3 2 3 or 2 3. So this will be 2 plus 1. This will be 2 plus 1. And this will be 1 plus 1. So our even divisors would be 3 into 3 into 3 into 2. So 3 into 3 into 3 into 2, that's 54 even divisors will be there. So the answer for the third part of the question is 54. Anybody who wants me to revisit this again, do let me know. Yes, Vaibhav, I again repeat it. See, if you want your factor, see, how do you make a factor? Whatever you have picked up, you multiply it. That's your factor. Let's say I pick 1 2 fruit, 1 3 fruit. Okay, and I pick nothing at all. That means 2 into 3, 6 will become. Correct? So if I want to make a factor which is even, I have to pick at least 1 2 fruit. That means I can pick 1 2 or 1 11. That will be an even factor. So 2 cannot be neglected. What I'm trying to say, you have to pick at least 1. So either you can pick 1 2 or 3. Of course you can't pick a 0. So fourth case will not come, like what came over here. So there are 4 over here, right? 4 cases are coming. Only 3 cases will come. You cannot have the fourth case where you're picking no 2s at all, because if you're not picking up any 2, you will end up getting an odd number for sure. Okay, so this is the total number of even divisors. In the same way, if I have to think from scratch how to pick odd divisors, then ensure that you don't pick up any 2. So one way to pick up no 2, and again 2 plus 1, 2 plus 1, 1 plus 1 to pick up the others. So that answer would be 3 into 3 into 2, which is 18. So let's say, sir, you should have done 72 minus 54. Yes, I could have done that, but I wanted to treat this from scratch. So why 1? Because no 2 should be picked up. No 2 should be picked up. Okay, because if you pick up a 2, the factor will become an even number that you don't want. So 18 ways to odd divisors. Now, how many of them will be perfect squares? Fifth answer I would like to see from you. Anybody with the fifth answer? Okay, Aditya, awesome. Okay, now for the fifth one, please understand, if you want to pick up a factor which is a perfect square, then you have to pick up even number of those pickings. What do I mean by that? See, any perfect square that you know of, let's say I talk about 25. In 25, 5 is picked up twice, right? Let's say I take a number, simple number like 36. 36 is like 2 is picked twice, 3 is picked twice. Okay, if I take, let's say, a number like 1296, which is 36 square. So here I'll pick 2 4 times and 3 also 4 times, isn't it? I hope this is correct. My calculation is correct. 36 into 36. Okay. So what I'm trying to say is that if you're trying to pick up a perfect square, you must pick up a fruit in multiples of 2. Correct? Now, come here. So you have 3 fruits whose name is 2. So you can either pick up no 2, 0 is also a multiple of 2, or 2 2s. So 2 ways to pick up 2. What are these 2 ways? Either you pick 2 to the power 0 or you pick 2 to the power 2. Correct? 3, either you pick 3 to the power 0 or 3 to the power 2. Again, 2 ways. 7, either you pick 7 to the power 0 or 7 to the power 2. Again, 2 ways. 11, you should not pick it at all. That is 1 way. So your answer will be 8 of them would be perfect squares. Guys, try to understand here. Again, I am repeating it. See, if you want to make a perfect square factor, then whatever fruits you are picking up should be picked up even number of times. So either you pick 0 or you pick 2 or you pick 4 or you pick 6 or you pick 8, like that. Correct? Now let us focus on 2. Let's say 2 is a fruit name. Let's say apple. So there are 3 apples, right? I can only pick 0 apple or 2 apple. I cannot pick 4 apple because of course there are total number of 3 only. So I cannot pick 4. That's common sense. I cannot pick 1 also. Correct. So either 0 apple or 2 apple. So 2 ways. Similarly, let's say this is orange. So either 0 orange or 2 orange. Similarly, let's say this is guava. Either 0 guava or 2 guava. And let's say this is 1 pineapple. There is only 1 pineapple. So don't pick any pineapple, because if you don't pick any pineapple, that is counted as an even number of picking. So 2 into 2 into 2 into 1. Answer is 8. Very good, Aditya. Aditya cracked this problem. Nice. What is the sum of all the divisors? That again, we can use our formula. So let me just take this up over here. Which number was this, by the way? Sum of all divisors. It was 6th number. Okay, so 6th. So sum of all divisors will be, as I discussed with you in the formula. So take, let's say 2. 2 is occurring 3 times. So you can start with 0 and go all the way till 3. 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. Similarly, 3 is occurring 2 times. So 3 to the power 0, 3 to the power 1, 3 to the power 2. Similarly, 7 is occurring 2 times. So 7 to the power 0, 7 to the power 1, 7 to the power 2. 11 is occurring 1. So 11 to the power 0, 11 to the power 1. So basically 4 into 3 into 3 into 2. That's the total number of factors you'll get. So let's find the sum out. This is going to be 2 to the power 4 minus 1, which is 15. This is going to be 9 plus 1, 10, 10 and 13. This is going to be 49, 50, 57. This is going to be 12. How much is this product coming out to be? So I'm using my phone for this, but just to save time, guys. So my answer that is coming out is 13380. Is this what you're getting? Oh yes, Vaibhav, correct. 13380. Any questions, any concerns? Okay. Now comes the last part of the question. In how many ways can this be expressed as product of 2 of its factors? Now, try to understand this question. See, this question is like saying, I'll take a simpler example. Let's say I ask how many ways can you express 54 as product of 2 of its factors. So you can say, I can write it as 1 into 54. I can write it as 2 into 27. I can write it as 3 into 18. I can write it as 6 into 9, right? Now, after this, if you write 9 into 6, it will consider to be the same. So 9 into 6 is the same as this. This is same as this. So this is not counted as a separate one. 18 into 3 is same as this. 27 into 2 is same as this. 54 into 1 is same as this. So basically you will have 4 ways to do it. Okay. So I've just taken a simple example. Okay. Now I would like you to tell me, taking a clue from this, what would be the total number of ways in which n can be, or let's say 38,808 can be written as a product of two of its factors? What will your answer be? Total number of factors is 72. Correct. I'm asking you, in how many ways can you write 38,808 as product of two of its factors? So take a clue from this example. This is one way, this is another way, second way, third way, fourth way. So there are 4 ways here. Okay, please note that these are not considered to be different from these. So this is not to be taken into account. Okay, these are all same. So from the same logic, how many ways can you write 3808 as a product of two of its factors? Now Advik says 36. Yes, his answer is correct. Okay, but here is a catch that I would like to discuss with you. See, many people think that the answer to this is always, so let me name a topic here, in how many ways or number of ways to express n as product of two of its factors. Now many people think it is always total number of factors by 2. Okay, this is what many people think, but this is not always correct. I'll give you an example. Let me take a simple number. Let's say I take 100. Okay, now 100, if you apply this formula, first of all, 100 is 2 to the power 2, 5 to the power 2, correct? Total number of factors here will be 2 plus 1, 3 plus 1. Oh, sorry, 2 plus 1, 2 plus 1. My bad. Which is actually 9. Correct? If you do 9 by 2, you'll get a fraction. Correct? That cannot be my answer. Fraction cannot be my answer, right? How can the total number of ways be a fraction? All my answers should be whole numbers, by the way. Okay. So this formula fails here. Right? You know why it fails? It fails because when you write 100, let's say, let me write it and show it to you. First is 1 into 100, 2 into 50, 4 into 25, 5 into 20. Then you'll have 10 into 10. Okay. And after that, again, you start repeating 20 into 5, which is already same as this. 25 into 4, which is already same as this. 50 into 2, which is already same as this. And 100 into 1, which is already same as this, right? So these will not be counted, correct? So your total number of ways will be 1, 2, 3, 4, 5. Now here, this guy is not getting repeated just like the other were getting repeated. So this was getting repeated as 20 into 5. This 4 into 25 was getting repeated as 25 into 4, correct? But 10 into 10 will not get repeated because it's a unique combination. You can't switch positions and say this is repeated, no. So here the problem is the total number of ways would be 1 more by 2. Okay, so here is a formula that I would like to discuss. So please note it down. So the answer for this question is the total number of ways would be let's say your n is expressed as p1 to the power alpha 1, p2 to the power alpha 2, dot 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 till pk to the power alpha k. So the total number of ways would be alpha 1 plus 1, alpha 2 plus 1, all the way till alpha k plus 1. Okay, by 2 if n is not a perfect square. Okay, so here we have to watch out whether the number was a perfect square. Remember, 100 is a perfect square. That's why this formula will not work. So if n is not a perfect square, then only apply this formula. Are you getting my point? So if n is a perfect square, then what will you do? If n is a perfect square, then what will you do? Then you'll do alpha 1 plus 1, alpha 2 plus 1, all the way till alpha k plus 1. Okay. Now, this is what normally we do. We subtract a 1, we divide by 2, and we add a 1. Okay. Which many books will directly write it like this. Now, why did we subtract a 1? Right? Because you removed the last guy. Correct? And whatever is left, that is always a multiple of 2. Divide by 2 and then add this one back. Okay. So many books will do this. They will directly write this as the same thing is directly written as alpha 1 plus 1, alpha 2 plus 1, all the way till alpha k plus 1. Now, if you take an LCM over here, it is automatically going to be 2 over here. So it will become plus 1 by 2. So any one of them you remember, that is fine. Okay. So this is the formula if n is a perfect square. Okay. I've already written it, so I don't want to write it again. Is the idea clear? Okay. Since the previous number which I had given you as a question was not a perfect square, that's why Advik's answer was correct. It was 36, but not in all the cases. Got the point? Okay. So we'll take one question if at all we have a bit of time left. Okay, let's take this one. Find the product of all even divisors of n. Find the product of all even divisors of 1000. Okay, let me put the poll because, yeah. Find the product of all even divisors. Yes. Anyone? Okay, let's stop the poll in another 30 seconds. Yeah, Aditya, go ahead. I mean, whatever comes in your mind. Okay. 5, 4, 3, 2, 1, go. Okay, most of you have gone with C. Okay. Now, those who have voted for C, what is the reason behind voting for C? Let's hear it out. Anybody who has voted for C, can you explain why did you choose C? So 1000 as a number is 2 to the power 3 into 5 to the power 3. Correct? Yes or no? Correct? Now, if you want an even divisor, that divisor should have at least 1 2 in it. Correct? That means I can have a divisor like 2 to the power 1, and I could have any number like 5 to the power 0, 5 to the power 1, 5 to the power 2, 5 to the power 3. Correct? Right? Or I could have 2 to the power 2, again 5 to the power 0, 5 to the power 1, 5 to the power 2, 5 to the power 3. Correct? Again 2 to the power 3, I can have 5 to the power 0, 5 to the power 1, 5 to the power 2, 5 to the power 3. So these are the numbers which are all even divisors of n. Now if you multiply them all, what will you get? If you multiply them all, what do you get? Okay, I'm just writing it down, but we'll just figure out what is the shorter way to do it or through the formula. See here, you're multiplying, let's say, all these terms together. So what are we doing? We are multiplying 2, 2, 2, 2 square, 2 square, 2 square, like that, like that. Okay, so when you multiply everything, what do you get? 2 to the power of 4, sorry, this is 2. 2 to the power of 4, and this is going to be 8, and this is going to be how much? 12. Okay, so you'll have 2 to the power 12. Similarly, you'll have 5 to the power. Now this is 6 plus 6 plus 6. Correct? Yes or no? Am I right? I hope I have not missed out anything. Correct? So this becomes 2 to the power 24 into 5 to the power 18, if I'm not mistaken. Correct me if I'm wrong. Correct? So the answer here that should come out should be 2 to the power 24, 5 to the power 18, which is none of these. Option D is correct. Have I missed out anything? Please highlight. Sorry, I didn't get you. See, when you're multiplying all of them, yeah, I'll explain once again. See, these are all these factors which are multiples of 2. Okay. When you're multiplying it, I'm just considering 2 to be multiplied together, 5 to be multiplied together. Correct? So if you multiply all the 2's together, so this is 2 to the power 4, this is 2 to the power 8, and this is 2 to the power 12. Correct? No? So altogether the power on 2 would be 2 to the power 24. Correct? Similarly, I'm multiplying all the 5s together. So 5 to the power 0, 5 to the power 1, 5 to the power 2, 5 to the power 3, that will be 5 to the power 6. Again, I'll have 5 to the power 6. Again, I'll have 5 to the power 6. So 5 to the power 18. Is this fine? That's what I'm saying. No, Pranav. 2 to the power 6 into 2 to the power 18. Won't it be 2 to the power 24? Oh, you are saying one of the options is matching. Okay, fine. Let us check it. Check that. So 64 is like 2 to the power 6. 18 is like 2 to the power 6. 5 to the power 18. Oh, yes. Yes, absolutely. Sorry. So this is 2 to the power 24. 5 to the power 18. Oh, my bad. So one of the options, that is option number C, is correct. I'm sorry. Option number C is correct. Okay. Yeah, yeah. Okay, okay. I understand. I understand. Right. So this is basically our